Hello, everyone, and welcome to Open Observability Talks. I'm Dr. Horvitz, and here at Open Observability Talks, we talk about anything DevOps, observability, and open source. So may the open source be with you. I'd like to thank our sponsors, Logs.io, the cloud-native observability platform. Logs.io takes the best-of-breed open source projects such as Prometheus, OpenSearch, and Jaeger, and OpenTelemetry, and offers them as a unified observability platform built for scale. For those joining the live stream on YouTube or Twitch, feel free to share questions and comments here on the live chat. It will definitely make things more interesting for us here on the chat, and we'll call this and embed it as part of the conversation and live chat here. And with that, let's move on to today's episode. For the past year, I've been following .NET and how it embraces observability and cloud-native development in general, and actually bakes that into the language as a first-level citizen. Many of these teasers, to be honest, and updates came from the active Twitter of David Fowler, one of the most influential champions of .NET, and was also delivered the big news at the .NET Conf keynote a few months ago about the new .NET Aspire framework. And seeing the upcoming GA of .NET 8, I decided to invite him over to share with us some of these updates. Hey, David, good morning.
Hey, good morning. How's it going?
Good, how are you?
Happy to be here.
Where are you joining us from?
From the Pacific Northwest. I'm in Seattle.
Sounds good. So, tell us how you got to become such a major influencer in the .NET community.
That's a good question. By mistake. I would say so. My career has been in this space the entire time. I'm from Barbados originally. I went to Florida for college. I think this is a very typical kind of story. Like, moved from Barbados, went to Florida for university. Ended up getting an internship at Microsoft, and I interned twice. It's funny, on the .NET team actually. So I've been working on .NET for like 17 years now, and interned twice, and then I got a full-time job, and I've been working in the developer tools space, developer framework space for my entire career. So I think that lineage, I kind of grew up in this space. I remember, I think my Twitter or X account has been open for 14 years, I think, this year. So I've been on Twitter for a long time, or X, blogging about my work. And I guess when the change from blogger to influencer happened, I just kind of kept doing what I did, right? So I work on this stuff. I help build it. I talk about it, and I enjoy kind of doing both.
That's amazing. That's it's like people ask me how I started doing DevRel, and I told them I did DevRel before it started. They even invented the word DevRel. When I was a solutions architect and a system architect, and I just started sharing things on blogging and doing meetup talks and things like that. And then at some point they started calling these things developer relations, developer advocacy. So, yeah, I guess that's that's another story. So. First of all, to be honest, and also with our audience, I'm not a .NET developer, so some of my questions might seem basic. Apologies for that.
That's awesome. No, it's fine.
But so as non-.NET developers, even before going to the new stuff, can you tell us what the experience of developing microservices, containerized applications, developing cloud workloads in .NET has been like before the new stuff that is coming?
Yeah, so I think the funniest part when people think about .NET, and this is a big thing that the team's been working on for a long time. .NET is 20 years old. If you want to think of it like a Java, like it's that age in lineage in a language and platform. So its roots are buried in Windows and Windows servers and Internet IIS, the web server built into Windows. And I think a lot of people think about .NET and immediately think about that .NET, right? What we call .NET framework. That is the OG, the original .NET that's built into Windows. It's version .NET 4.8. It's been there for a long time. It's steady, stable. I don't want to say completely unchanging, but it's kind of like set in stone at this point, right? We get minimal updates, small changes and fixes, but that is the the current Windows specific stack. Over the last 10 or so years, there's been this massive transformation of .NET going from Windows specific, only running on Windows servers, only tied and coupled to the Windows schedule and lifetime, to now we have this open source, multi-cloud, multi-platform framework. And I recall when we started working on cross-platform .NET like 10 years ago, I had this meeting where we were rebuilding the web framework because we had this web server tied to Windows, so we had to build a new one. So we built this new web server, this new web framework, this whole vertical stack, and I was demoing to our president, right? And he was seeing our thing for the first time, and the question was, "What's a container? What's Docker?" Right? And Docker was still was kind of nascent at that point. It was happening, but it wasn't happening for .NET because we had been tied to Windows. And Windows containers are a thing now, but back then, it wasn't a thing at all, right? So the question was, how are we going to pivot the platform to target these new innovations happening in a space where we were not, right? We didn't even exist. So 10 years ago, we started our open source cross-platform journey to bring this platform that was tied to Windows, built into the operating system, to everywhere else, right? Linux, Mac, Windows still runs on both, not coupled to the Windows ship schedule. That was a big reason for doing this work. .NET framework ships in Windows. It ships with Windows as a Windows component. There are things in Windows that depend on big .NET, right? New .NET, 8 and above, .NET 6, 8 and above, originally called .NET Core. That is the open source stack. The code is all on GitHub. It is open source. You can build your own version of it. Ships in package managers on Linux, which is kind of a big mental shift if you've ever thought about .NET and C# as this thing tied to Windows. But that's the transformation that's happened over the last 10 years. And we've made,
they say that the biggest distribution of Linux these days is actually deployed on Azure and things like that. So
yeah,
exactly. Amazing numbers that you see and vice versa. So the world is no longer the old world.
Yeah, exactly. I think just watching the entire platform and even so Microsoft is built on .NET. It's funny that there was a news article about how some teams are trying to use Rust to build services and replace C#, and there was this big outcry oh my gosh, is C# not going to be used? And it's a very tiny subset of the overall company. But I would say the company is built on .NET. All of our services are built on .NET and C#. And as the company internally moves to more modern designs, Kubernetes, microservices, containers, we, the platform team, get to support both the internal customers and external customers trying to make the same move. So we get these kind of two point of views, watching people trying to be modern, right? Yeah.
So before, again, we're going to get into the new stuff, but up until then, up until .NET 7 or so, what was the experience if I wanted to build a microservice architecture type, containerized workload? What would the experience used to be like?
So a lot of what we built up until, let's say, .NET 6 before 7, I would say felt a lot like what you would see in any other stack, where you would have to manage Docker files yourself to build a container image. It isn't new, right? It's everyone does it today on their platform. It was a little rough for .NET because of how you build projects, and containers and project references weren't really, I would say, languages that kind of grew up a certain way in that environment felt more native when you built containers and stuff. .NET was workable. It was definitely doable, but it was you had to learn more stuff to even kind of, on top of Docker, on top of just learning .NET and Docker, you had to understand why you had to build container images in a very specific way when using .NET. So it was definitely doable. Building services was also, I don't want to say it was hard. It was very easy. We have a very nice web stack for building services. ASP.NET Core is the web stack for .NET. It's a very nice framework you can build. APIs, gRPC services, WebSocket services. It is, I think, one of the most expansive platforms. And so it's funny, I spend a lot of time looking at other frameworks. .NET has this unique perspective where a lot of things come out of the box. So the ASP.NET web framework does a lot of stuff for you by default. So you don't kind of have to go searching for different things to kind of do web servers or gRPC and stuff. That's just, they're part of the entire stack. So you could always build really high quality services, and people have been doing it. I would say where it got tricky was as people moved to cloud and they wanted to adapt to things like OpenTelemetry or trying to be more standard with how we emit certain things from the app. That's where it got a little tricky, because .NET was around before OpenTelemetry, and we invented stuff before that, and it was fine. It was inconsistent. It was fine, but I would say a lot of teams made it work. If you want to get information from the runtime, use that API. If you want to get it from the web server, use that API. And then you have to cobble together that information in process and then put it into your telemetry systems somewhere off box, right? But there was never this consistent shape for how that looked. Funny story, before OpenTelemetry was a real thing, there was OpenCensus, right? And that was like being built.
Right.
And normally in .NET, we don't take dependencies on things in the platform that aren't standard or ratified or have had some cycles going around, because like it's dangerous for us to take dependencies on any format, any dependency that might go away, because we support things for a long time. So we kind of watch these standards evolve, and we're always trying to see when is it going to be ratified, when is it going to stick, right? So back in the early days of like .NET Core 3, we had one of our architects grab tech from inside Microsoft, and it was to make distributed tracing work. There was a big push towards cloud, and end-to-end tracing was like super important. So how do we track correlation between multiple service calls? That was the thing that we had to solve. And at the same time, there was this standard called I think it was called trace context, the W3C standard that was being invented. And we had people from multiple companies collaborating on this spec. So we had people from Microsoft, from Google, but it was still like super nascent, right? Everyone had their own header format. Everyone had their own token format. And we had our own as well. And .NET took this leap and embedded this token format into the core platform. And it's still there to this day, right? And this might be a lesson as to like why you don't preemptively grab random proprietary formats. We invent this token format and we bake it into the web framework and the HTTP client, so you can get this end-to-end tracing. And then our backend service on Azure App Insights also understood this format, right? So one of the ways we kind of build software is we really avoid coupling. So like this thing only works on this platform if you have Azure. What we build are experiences where if you have all the things in the right places, it works together. So everyone agrees on loose contracts. And we just so happen to implement all the loose contracts in all of our stuff, but you could do it yourself as well. And that has been a big shift in how we build software, coming from like closed source, one single vendor. You know, it only has to work with other team software, to how do we design systems that anyone can plug into and anyone can extend or implement. But when we do it, it's amazing, right?
Yeah.
So we put this thing in .NET, and then I want to say like a year later, the W3C trace context spec is like ratified. Now we all agree on the trace format and the header.
Yeah.
And that was the first thing that we like put into .NET. So now there's like two formats. There's legacy format and official trace format that we support.
Nice.
Yeah.
So we'll get back to you mentioned also OTel, OpenTelemetry and things like that. But so I want to again, I mentioned in the opening that I've been following your tweets, and generally the work of your team has been working think 3 years already, adding metrics, traces, as you mentioned, to everything from HTTP client, HTTP server, and so on. So what's the journey past this agreement, the initial agreement that you talked about, to reaching this point where you have out-of-the-box observability in .NET, leading up to what we'll talk about soon with Aspire. So just tell us about the journey.
Yeah, so from that .NET 3 timeframe where we had this like out-of-the-box distributed tracing with both the legacy format and the W3C official trace context format, that I think was the entryway to, okay, we want to make our stack by default cloud ready. How do we build systems where if you came to our platform and you use our core platform or any libraries in the platform, they would be like automatically instrumented. That was the dream. So we started working on systems where we would encourage, the way we build things is we will add this core API to kind of emit telemetry in some form, and we'll use it ourselves to make sure it's good. And then we'll say, okay, we got it in the core platform. Can we now get popular third-party packages to also adopt the same patterns? And it kind of spreads from there. So it started off with this thing called activity. Activity is the equivalent, if for those who are listening, OpenTelemetry has kind of a few primitives for creating different kinds of telemetry. There's distributed traces if you want to trace a transaction from service to service, and those are spans. And then there's emitting logs and metrics. Those are kind of the three things that three APIs that exist in the OpenTelemetry libraries, right? And what OpenTelemetry ended up doing is they wanted to make the library standard across every language. The libraries, the protocols, anything that you could emit from an application, they were going to make standard, right? And that was a big jolt in the seat for platform owners like ourselves and for vendors who own APM systems, right? Like everyone had their own API to send telemetry to their backend system. That was going to be standard from now on. It's really good for us, right, as a platform vendor, because we can say if we emit this standard format, we can support end vendors without having to worry about supporting each one, right? Makes it easier. So there's a team at Microsoft responsible for our backend APM system, application insights. That team had the same dilemma, right? Okay, we have an SDK, we need to support this open telemetry thing. So they invested, so they have there's an entire team at Microsoft whose job it is to make sure that open telemetry can be adopted in Microsoft, right? By our backend services, by teams trying to build services. So they end up helping build the .NET client, the client for C++. So any language that we use internally to build services, that team has a hand in helping the clients move forward. They also work on the spec. So now we have this team invested, and they're building the client for .NET. And I think in a unique position that we have, the .NET team is also at the same company. So we get to talk to the people who are helping build the .NET support and helping push the spec forward to kind of give feedback, get feedback about things. So we land on this strategy to embed primitives in .NET for emitting traces, metrics, and logs. And the plan is to instrument everything that can be instrumented at the runtime level, the server level, all the clients, all the networking stacks. So if you just turn on .NET by default, you can turn on telemetry and you get counters and metrics for various subsystems. You get logs from everywhere, and you get traces as well. So that was a big multi-year shift. But we planned that strategy started off in .NET 3, and it's been kind of led up to where we are now. And I would say we had been crawling, crawl, walk, run, get it working, make sure it's like solid, make sure it works, tweak the information. And we had teams, internally and externally adopt these patterns, but it was never easy, right? You still had to have a little bit of I don't want to say a PhD in understanding OpenTelemetry, all the backend systems, what to wire up, how to sample traces. There's all this science in making tracing work well for your system, and there wasn't an easy way to get started. So we had been up to this point turning on more traces, more features, and I think we got to a point where, okay, now we have a lot of traces. How do we help people adopt what we did for the last 5 years? This isn't brand new. It was just, it was in the product. It was just really hard to kind of explain to someone, how are you supposed to turn it on in a way that will be useful to you for your applications? Yeah.
No, that's amazing. And actually, now that you say that, and I'm an advocate of OpenTelemetry, and I've been running around. Actually, even yesterday I was giving a talk about what's new in OpenTelemetry. But trying to go back to that decision point, that's actually not a trivial decision point. Now you know that OpenTelemetry is a de facto standard, and you can rely on traces, metrics, even logs. But logs just GA'd we announced it in the last KubeCon, which is less than half a year ago. So I'm going back to that point in time, and knowing that you actually had your own implementation. You mentioned some of that. So very stable in-house implementation, also with the organizational culture of having something that you can rely on. Can you tell us about the journey with Otter, like the decision point in that point in time to make that leap of faith, if you may, or how did you as an external person to OpenTelemetry and to the CNCF ecosystem viewed it from outside and reach the certainty that this is the path to go?
So I would say it started off by dipping our toes in. So it was, let's just do tracing, because that thing is moving the fastest, right? Do tracing first and see where it leads us. After some success with tracing, and we had this API built into .NET that was kind of a mirror of the tracer API in OpenTelemetry. And I think once we got that working well, and there's a lot of back and forth and a lot of, I want to say, doubt sowed. Whenever there's you make a big bet and maybe there's some confusion as to like if it's working or not, there are doubts sown in people's minds, right? Like, should we be doing this? Should we pull out? Should we change it? Do our own thing? But I think over time, incrementally, as we went version to version, we kind of had in the back of our heads, as more of the spec gets ratified, we will just lean into it because it seems as though adoption is happening. I think one funny story about this is when we were looking at OTLP, and OTLP had been around for a long time, and I'll get
OTLP, just for our listeners who don't know, OTLP is the OpenTelemetry protocol. So this is the standard way to transmit telemetry data.
Right, and it had been around for a while, but I didn't see mass adoption of it for a long time, right? It hadn't been picked up by every vendor yet, and we had our eyes on it as a thing that maybe we'll support one day, but it had never popped to the surface. So we had this very conservative, incremental way of adopting parts of OTel, and I think strategically we worked with the people, the team in Microsoft who was on the OpenTelemetry board from Microsoft. So we had a direct channel to like people working on the spec, on the product. So I think that helped us feel more comfortable as to like what to adopt, how much to adopt, what to stay away from, because it isn't done yet and it's changing rapidly. So we did this very incremental approach to adopting pieces of it over time. Last year actually, was the call we had to make, a big call. We had this email thread, and it was about the OpenTelemetry semantic conventions, right?
Oh, yeah.
It was still in flight. We were doing .NET8 at the very, I want to say, in the last couple of months when we're in like shutdown mode, no more changes unless you go through all the bosses, right? You have to like send an email, and it has to go through layers of approval to like get in. We had this email thread, and it was, okay, the semantic conventions for HTTP are now at 1.0. What do? Do we want to change? Because we had invented schemas for all of our stuff, and it was not going to be based on conventions. Do we shift? Do we not shift? what do we do if we adopt a convention and it changes? Like, are we going to break people? Like, what do we do? And the team's default nature, like culturally, is to be very conservative. So like, oh, we shouldn't adopt it is the default answer. We should just not do it because what if it changes? And we bit the bullet. A group of us kind of said, okay, we're gonna just like adopt the entire semantic convention for HTTP. It's in 1.0 format. We updated all the APIs last minute in .NET 8 to have the right tag names, and we agreed to patch .NET 8 as it changes. That was the agreement, right? Because we thought it was very important to adopt the conventions as they became ratified. And it for us, it isn't officially an API breaking change, and we have a way of modeling compat, so we can say like, if you turn this switch on, you get the old stuff, so you don't have to break yourself in production. So if you had dashboards using the old stuff, you can still make that work. But we thought that was it's very bold, very different.
Yeah.
Different
and it took ages for us to get the semantic conventions for HTTP past the finish line for 1.0. So that's
thank you.
Yeah. That's to be very honest. So let's go straight to the biggest news. I guess the biggest event for .NET is .NET Conf for those who are not .NET developers, and this is the community event that runs alongside Microsoft Ignite, right? And then I guess Aspire was perhaps the hottest announcement there in the last one a few months ago in 2023. So give us the pitch. You practiced it last week, you said. So what's .NET Aspire, especially for non.NET folks?
So I've been thinking about this pitch for a long time, and we have this like this super long sentence on the blog post describing what Aspire is. But I think in general, the way we talk about Aspire is it's a stack. And the stack word is important because it's not a new thing on its own. It's not an old thing. It's made up of both old and new things. So we just spent the last 5 minutes talking about OpenTelemetry. Aspire didn't invent OpenTelemetry, but we take advantage of it. So we take all the stuff we built over the last 10 years, and we're trying to put it together in a stack to make it easier for you to develop applications that are cloud native, right? And it includes several top level components like orchestration, so it can help you orchestrate multiple services to run locally. That's one of the things we thought was difficult to do when you're trying to get started. When you're entering this cloud native microservice space and all you want to do is run 2 or 3 things, the barrier to getting started is really high, right? One of the things that me and one of our product architects talk about on the team is progressive disclosure. And that's one thing I think we do at Microsoft really well when we build developer experiences is if you were super experienced and you understood Kubernetes, Docker, Helm, Terraform, OpenTofu, like if you understand all that stuff, you could look at Aspire and you'll go, it's gonna hide details from me. I already understand how to do all this stuff. Like, why do I need this thing to happen? What it does for someone who doesn't know is it lets you get started quickly, and you get this dopamine hit of like, oh, I got a container running for Redis and my projects, and Postgres, and I can run locally, test, get service discovery working between services, and then once you get it working, after you've had that rush, you can peel the onion and say, what image was used? Like, picking smart defaults, getting you to a place where you can deploy quickly without having to learn infra's code, or like all these things that kind of block you from even doing the first step. Yeah. The mantra is very much get you up and running quickly with very smart defaults, and then make it such that you can, break glass and take control, right? I understand I want to use Pulumi instead of using your thing. So how do I plug in this other system that I'm using into your current system? So I think we're getting to a place where we get you off to a very fast start in a really good way with conventions, and templates and tooling and default telemetry and dashboards. And then you start with that. And then you can choose, which part of the experience do you want to keep? Which ones make sense for you in your environment, etc.
So it's primarily, just to make sure I understand, it's for dev test cycles, right? It's the focus is to get the programmer, the developer up and running with writing the microservices and all of that without having to mess with all the underlying wiring to get it to work, right?
That's correct. That's correct. So it is optimized for developers, built for developers. That's not to say that it's not DevOps friendly. We do foresee a path where developers can kind of hand off assets or hand off. It's funny. It can go either way, I guess. Like either the developer is handed it, the environment to kind of deploy to land in, or you have assets. And the thing we learned about some of these cycles and team cycles of how people develop these applications is it can change depending on team size, team dynamic, split in roles. So we're learning a lot about seeing the customer cohort that kind of loves having everything in C# and everything built in this walled garden kind of way, and they don't need to interact with anything else, versus people who have something and are trying to integrate. And we want both things to work. So one of the things we learned really early on after the first preview was we kind of learned how people were using it, right? Local dev is the optimal scenario. Is if you want to spin up some containers quickly and connect services that run, it is amazing for that. Deployment is where you kind of have to choose, like, do you want to use our deployment tech or do you want to integrate with your deployment tech? We're still figuring out exactly what that looks like, but I think we're on a path to supporting the easy case that, if you do want to use the entire stack, it works pretty well. And if you want to interop, you can as well, but it requires you doing some more work to kind of integrate your system with Aspire.
So just to break it down, and I'm an engineer, so I'm trying. When I looked at it in preparation for our episode, and also following Aspire as it was announced, and looking at the shopping list for Aspire, and admittedly, I'm not a .NET developer. It might be a silly question, but I see many things that I ran into in .NET, like health checks, OpenTelemetry, even configuration, dependency injection, were things that I encountered before. So is that really a new stuff, or what? How does that relate to things that I might have seen before?
I love it. So great question. When I mentioned Aspire is a mix of all the new stuff, Aspire puts together things that are what we call Lego pieces, or these atoms of .NET, into this like experience. And that's why it's hard to describe, because Aspire isn't really a whole new thing. It is grabbing all the things we have already and putting it all together to say, here's how you build a cloud native app in .NET, and that has telemetry on by default, that has, whenever you wire up a database, a cache, a pub subsystem, we turn on health checks, OpenTelemetry. We have this default dashboard that shows up, that shows you metrics, logs, and traces. That only works because we did all this work 5 years ago in the platform, in the ecosystem. All these libraries support these traces. So we put together this stack based on existing stuff, building experiences on top of that stack to make it work end to end. So when you create a new Aspire project, you get OpenTelemetry on by default, wired up to metrics, traces, and logs for the web server, the client, the runtime, the process. So you get metrics for all those things. You get distributed traces on for gRPC, HTTP. You get logs turned on. We wire up what's called the OTLP exporter, which can send the OTLP protocol from all of your services to any configured server using standard OTLP environment variables. The developer dashboard in Aspire gives you the experience of trying to visualize your end-to-end traces, logs, and metrics. So when you're developing in your inner loop, what we call the inner loop, when you're deving locally on your machine, that's referred to as the inner loop in my org. When you're developing, we are trying to shift a lot of stuff left, right? So we want to do as many things as early as possible when you're developing. So if you add a metric, a log, a trace with structure, and you want to see tags, or you want to like observe what you just did, you don't have to deploy to a cloud. You don't have to, publish to some environment where you have things running in production. You can just, in your local environment, visualize traces, all the properties of each trace. You can kind of visualize everything to debug and make it work. This was one of the major things we found when trying to make distributed apps work. That was a big hurdle. A lot of teams end up spinning up a Grafana dashboard, Prometheus endpoint, Loki endpoint, and just to see the output, right? Console is a really low fidelity experience, and it only works for one stream at a time. So you can't write logs, traces, and metrics to a console. They'll all like interleave and overlap, right? So how do you in local dev visualize those 3 metric forms in an easy way? Aspire, as part of our dashboard, has wired up an end-to-end experience where when you launch your app, the dashboard hosts an OTLP server, and all the apps are configured to send telemetry to the dashboard. So you get this like really immediate view of telemetry in your application with zero effort, right? So I think that's part of the mantra of Aspire. It is about getting you to where you need to be really quickly, and then you can peel back and figure out, okay, here's how it works. And I think we're lucky because doing it in 2024, we get to lean on so many standards. If we did this project 10 years ago, there wouldn't have been OpenTelemetry, there wouldn't have been CNCF. So we basically get to take all these Lego pieces, all these blocks, and build this end-to-end stack that kind of works together to create an experience for building apps.
Yeah, and you mentioned the UI part and the analytics and visualization backend, and maybe again because I'm not a .NET developer, but it's pretty common for developers where I come from, at least, to use Prometheus and Grafana stack or something similar. Yep. But you, as you said, decided to develop your own UI. I'm just curious about this decision point and what kinds of pros and cons you saw when you reached this decision.
It's a good one. So one of our product managers was adamant that we should build a dashboard, and I was like, no, we should by default have a Grafana dashboard, in local development, so I can visualize things, right? I think both have their pros and cons. One is if you need to customize Grafana, you have to write queries, build dashboards. It is a non-trivial exercise, right? We could have spent time building a developer dashboard for Grafana to run locally. And actually, one of our engineers built an ASP.NET Core starter dashboard using Grafana and PromptQL. So that shipped in as part of it as well. So we're still doing that as well. I think the main thing that came up was when you're doing development, you just want to see data. You don't care about authoring queries. You don't care about like having alerting views or looking at percentiles. You just want to see the raw information. Show me the logs, show me the properties, show me the numbers, show me the dimensions. Let me just dice that to see what I'm emitting, right? So I think the experience of immediate being able to visualize the data without having to pre-can, pre-query, build anything complex was, I think, a big reason for building a dashboard. Now, the dashboard is for development. But I will say the moment we show the dashboard to everyone giving demos, internally and externally, they wanted to have it in production. That dashboard is not something you can use at scale. It does not have offline storage. It does not have an index for metrics. It does not have, it's an in-memory volatile store that will recycle after some number of logs and traces and telemetry. So the way we see it is, in your prod environment, you can host the dashboard for just-in-time information. If you want to see what happened just now, right? Last, I don't know, probably less than 1 day or so, right? Depends on your traffic and stuff. If you want to see what just happened, you can host that dashboard as an OTLP endpoint. What we've been discussing is when you're in Kubernetes, and this might be if you're not used to cloud native things, I will try to like go slow and talk about all the pieces. If you are used to a cloud native Kubernetes environment, you might have an OpenTelemetry collector running in your environment, and all your apps are sending stuff to it, right? And that thing can fan out and send to other places. So you can send to App Insights, Datadog, etc. Logs.io, you can send to other sources, right? The dashboard can be one of those sources. So you can plug in the dashboard as an OTLP endpoint. That can be your just-in-time live developer view, even in prod.
So
It's
you
not
export
persistent
from the collector to two endpoints,
dashboard.
one for the real-time
Yeah.
analysis and one for the deep insights,
Correct.
historical analysis, let's put it this way.
Exactly. I love that. So we've been calling it just-in-time diagnostics. You want to see an exception or a crash that just happened, like looking in the dashboard, you might see it. If you want to analyze over time, write a query for what happened, see the trends of the last days, look at percentiles, that's when you use an actual APM system and you author queries and you have your live dashboard for prod. This is more like, I just deployed to prod, stuff isn't working, like let me see what's happening. This is that dashboard, right?
Interesting. So even now you see, although you scoped it, as we said before, for dev test, you already now see demand for that also for post-deployment into production. You see people starting to embrace that as well.
Yeah, it's been one of the primary feedback items that we got after the first preview. And I think it comes from a place of, if you think about the sizes of different teams and deployments and apps, .NET is very big in enterprise, right? And if you're in a small shop and you have not much traffic, the dashboard is fine, right? I think there's a scale at which it becomes untenable, right? Large clusters, large deployments, a ton of apps, you will overwhelm the dashboard like quickly, right? But there's this, I think, longing for a simple experience to just see the information that I think many APM tools don't optimize for, because it's really about storage. Like most APM tools are storage engines with a fancy UI. Storage is probably the hardest part of designing those systems, right?
Yeah, all the time series databases.
Time series databases.
Exactly. That's a whole different art there. And talking about production, I'm thinking about the switch from dev test to production. One of that is the deployable entities that we talked about. And for example, we talked about Kubernetes, obviously the Kubernetes config. So how do you do this transition from the very masked out, as you said, that everything is done for you on the dev test, into something that you can take deployable into Kubernetes?
Right. That's a great question. So right now, the pattern that we have for deployment in Aspire that we're shipping for the first version is you develop with this local orchestrator. That thing understands all of your applications. It understands your services, Redis, Postgres, etc. You run a command and it can spit out this manifest. And the manifest is a reified version, this JSON manifest that describes all the resources and links between resources. So you get information about dependencies, environment variables, all things that are set. And the question is, how do you turn this manifest into a thing that can be deployed somewhere? And there are various tools that either we're shipping in Microsoft or other people can ship or kind of write that can take the manifest and turn it into something more concrete. So the first tool that we're building for Azure is called AZD, the Azure Developer CLI. It can, you run several commands against your Aspire project. It will create the manifest, ask you for your Azure subscription and information, and it will automate the process of going from that manifest to an Azure deployment in Azure Container Apps. There's a second tool called Aspire, not a great name, but Aspire 8 for Kubernetes, built by one engineer in the community, really great guy, that takes the same manifest and turns it into customized kube manifest. So it'll take all your projects, build container images, push to our registry, and it will deploy those to a cluster of your choosing, right? Your current context.
So there is a converter that can take the Aspire project and turn it into a standard Kubernetes manifest.
That's right.
Oh, yeah, very cool.
Yeah,
nice.
So I think we will see patterns emerge from watching how people use those things. The question becomes like, how do you break glass? One of the most common questions when you have an abstraction is, okay, I have reached the limits, or I know what I'm doing. And developers are the most difficult customers you can ever have, because, you know, we love to have control over the things we understand, right? The moment
but you also love abstraction. So the balancing abstraction and flexibility. I used to be a product manager for platforms. And the most challenging things is that engineers want both control, which is flexibility, and they want abstraction. I don't want to be bothered with that. So how do you balance both? So that's
it's funny that's like one of the biggest things about working on a platform or framework is that same problem. You build an API, and the question becomes, are we the only ones that can do this, or can they extend it as well? And then we get requests to, like, you know, can you make it virtual, or can you make it abstract? And we're like, not yet. Maybe after we have 4 implementations, then we can build the abstraction to make sure it works for 4. Yeah, same problem, right? So I think what we'll see is people will build tools that take the manifest and will do cool things. There's one that takes the manifest and turns it into a compose file, right? Really cool idea. I could see Docker Swarm, which I think some people still use. You could spit out Nomad, the HashiCorp thing. So I think that'll be a place where I'm looking forward to seeing if people build things for their environments. And then we're trying to figure out still to this date, like, how do you break glass? What happens if you want to tweak the manifest? If I generate the manifest from the Aspire project and I change it, who owns the source of truth, right? Is it in both places? So we're gonna find, I think we're looking at interesting ways to kind of say, stick this, you know, if you're gonna translate to some underlying format, have ways to kind of, you know, just imagine you can express a chunk of YAML that will end up getting put into the kube manifest as you emit the actual data, as a way to say, okay, I know what I'm doing. Let me add an annotation to, like, my service, right, etc.
Great, and we have a question here from the audience. John Harris asking, can I ask how you see the relationship between Dapr and Aspire? I also wonder whether with Dapr, then Aspire, then Radius, there is a danger of framework overload.
Yeah, it's a really good question. And just so everyone, I guess, who was listening knows, like, Dapr and Radius came from the same space, the Azure CTO's office. They incubate projects. They build really great tech. Some make it out, some don't. Dapr and Radius did make it out. Those two things were being incubated for a while. I saw Dapr when it was, like, born, before it was called Dapr. So it was a really cool idea, and it's great to see it kind of where it is now. I think the philosophy of some of the tech that we have are just different. So right now, one of the things that I kind of express is Dapr is really trying to build a cloud abstraction. You don't use Dapr as a way to kind of make using Redis easier or Postgres easier. You use Dapr because you want to use the state store abstraction, or you want to use the pub sub abstraction. And if you build against that kind of minimal set, then you can be portable, right? That is the Dapr premise. Like, that Dapr is your cloud. It runs locally. It runs in the cloud, and you code against Dapr. Aspire's point of view is very much that we are not cloud abstractions. We are a multi-cloud. So you can target AWS, you can target Azure, and we will make that easier. We do not abstract storage. We don't abstract PubSub. We don't abstract databases, right? You use the frameworks you love and know. We haven't changed your frameworks. You still use them. We just add some stuff to those frameworks to make it do telemetry, health checks, and make it more configurable.
Yeah.
So we're
I look at it like Heroku. Those who used to, I don't know, whoever in the audience knows Heroku. Like we used to have the PaaS. I don't know, 10 years back, there's a trend of saying SaaS, PaaS, and IaaS. And Heroku was like the holistic. As long as you align with the full stack and you took the whole philosophy, very opinionated one, you were pretty solid. But the thing is that you need to be locked down in the very specific suite of capabilities. Whereas today you see a shift more to platform engineering rather than PaaS, because engineers still need this flexibility, because you have such a rich variety of databases, vector databases, NoSQL databases, columnar, whatnot, and you can't really limit into a fixed set and say, just choose one of these. So that's how I try to imagine that, for those at least who been through the Heroku phase.
It's so funny. I think we're all trying to rebuild Heroku, just like piecemeal with our own platforms. And I think you're right. And Dapr can be adopted incrementally, but I still think the philosophy of Dapr is very much, it is a platform abstraction. Like the reason you can run Dapr locally is because they abstract storage and PubSub and all these primitives. So coding against that thing works. Aspire really is trying to, in that space, not be new. So Redis, Postgres, like use the things you know and love, and we will enhance those things to make them turn on tracing and health checks and all the things you need for cloud, right? So that is the, I think, philosophical difference that Aspire versus Dapr brings. Now, the Aspire orchestration can orchestrate Dapr sidecars. So you can use them together. You can choose to use Aspire and Dapr, and I get it can be confusing, but I think once you see the integration, you understand why it makes a lot of sense, right? And then on top of that, I think the other project mentioned, Radius, is also pretty new, but I do think there is a lot of opportunity to integrate the same way that we do with Dapr. So I think you may see a nice end-to-end. I think one unfortunate side effect of how things got released, Radius came out the week before Aspire, and there was no real. And I know the architect really well that built Radius. Like we worked on the same team together before, and we're actually gonna speak next week about Aspire and Radius. So that's gonna happen. But it was.
So let's talk about maybe this is a good segue to roadmap. So do you want to tell us when the GA is expected? Maybe a bit what we're going to see released in that GA. I know that Preview 3 just came out a week ago, and you're working hard on Preview 4. So if you want to give us a sneak preview on what's coming ahead.
Awesome. So Preview 3 just came out. Go try it out. We added a lot of features that weren't there before based on feedback. A lot of what's being built now has been driven based on the Preview 1 and 2's feedback. We got a lot of feedback, and we're trying to make it like compress and figure out the themes and then build those things. Preview 4 is probably going to come out in the next, I want to say 2 to 3 weeks. This week is the last week of coding, so I've been coding like a crazy person, trying to finish features. I think one of the big things you will see in Preview 4, it'll probably be the biggest release of the bunch, because we are essentially taking some high-level scenarios and making sure the end-to-end works. I think the first preview of Aspire was like just making it function. There was a lot of new pieces and new patterns, and we had to figure out if that worked, right? Now that we know it works, now it's like polish. How do we make sure that, if I'm trying to develop against a container and deploy against a cloud service, that works? What happens if I want to develop against a container, or when I deploy, point to an existing service, right? That's a very common scenario. my ops team give me a bunch of connection strings or things to input to connect to services. I want to say when I'm deving, just use my container, but when I deploy, use that information. So we have spent time trying to figure out how to model those common end-to-end scenarios. So I think preview 4, you'll see a big like change in being able to express more things. How do I express being able to say, I need this thing to be, a hard-coded value in development, but when you're going to deploy, ask me for the value, right? Ask for a parameter. So we're modeling a lot of primitives based on that feedback, and you'll be able to write code to express, I think, a lot more than you could have before. You'll see on the issue list right now, people trying to get a scenario working, and it's like, oh, we didn't think about it, right? I think preview 4 will be the first preview where we can answer by saying, if you just wrote this code, it works. And that comes from trying to figure out the right primitives. Like the way we build systems is, figure out the 5 things required to build, the next 50 scenarios on top. Yeah. So I think preview 4 is where that's beginning to be real for the first time.
And GA, when do we expect that? So
GA, the current date we're sharing is before summer, before American summer, because I think in Australia it's summer right now. So you will see something definitely before summer for GA. I think the first version is going to be called version 8 because .NET 8 is...
It's released together with a GA of .NET 8, essentially. So
correct.
Aspire will come out together before the summer, in the Northern Hemisphere summer.
Exactly. Yeah. And .NET 8 came out in November, so you can think of Aspire as being late. But it's part of the same train.
Yeah, sounds good. And where can people keep up to date with Aspire, and where can people follow you? Let's leave people with some way to touch base and follow up.
So for Aspire, there is the I'll put it in the chat that you can post. There's a GitHub repository, GitHub/.net/Aspire. That is where everything is happening, discussions, issues, the code. There's a roadmap also posted on the repository. I'll get a link for that as well. So you can see what our plans are for the first release and what's not in scope. That's a big, useful thing to look at. And you can follow.
By the way, for those who are listening on the podcast apps, of course, all the links will be as part of the show notes. So don't worry, you'll get the links as well.
And then you can follow me on X, Twitter, David Fowler, and I'll be tweeting about this stuff a lot because we are actively building it. A lot of what we do is we build previews, kind of release to the public, get feedback, make changes. We also do studies where we kind of bring people in to we'll do a call, we'll show them code, or we'll have them carry out a task, and we'll see how intuitive the APIs are how intuitive the experience is. So there's a lot of feedback coming from multiple sources to build a good experience.
Amazing. Yeah, and I highly recommend, definitely follow David on the on Twitter. He's sharing some amazing stuff, including screenshots and very, very impressive stuff that caught my eye. And I'm not a .NET developer, so definitely awesome. Thanks so much, David. And before we wrap up, I do want to just say a couple of breaking news, as we always say, and do stay with me for these ones as well. The first one, I was very excited to see that Kate's GPS project has been accepted to CNCF as a sandbox project. For those who don't know, this is a way to sort of bring all the Kate's GPT, that all the LLM type of generative AI capabilities into the Kubernetes SRE type of investigation. So really, really cool project, and glad that it's now officially part of the CNCF stack, at least on the sandbox. And curious to see how this maybe the seed for adopting some LLM capabilities within SRE and DevOps practices. So pretty cool. And another one very excited is Strimzi that reached CNCF incubation. And Strimzi enables deploying and running Apache Kafka clusters on Kubernetes. Kafka is probably, most of us know that. So, and the project now has more than 1,600 contributors from 180 plus organizations. 15 public adopters already use that in production. So very, very impressive stats, and a big congrats to the maintainers and to Red Hat, which originally open sourced and contributed the project to the CNCF. So really exciting to see that one as well as part of the ecosystem. And lastly, as the time permits, OpenFeature, also very important project on the product management side, let's say, feature flagging, that became a CNCF incubating project. And maybe having been a product manager in past life and an advocate of open standards, I think this effort to create open source specification for feature flags is very high value in my view. Anything of that caught your eye or you got to check out?
Oh yeah, so I've been following OpenFeature for a while. We built a feature flag library in .NET, and there was no standard. But now this thing is like looking like it might be promising. This is actually a really good thing to kind of dial into. This might be an Aspire in the future.
So write me on the credits at the bottom there.
Thank you.
No, it's really, I've been seeing that, but the fact that you'll have a standard and then you're independent of how you actually manage the feature flags. You expose them once and then treat them in whichever way you want afterwards. That's amazing. And then maybe one word about upcoming events in March. We're broadcasting that on February, and March 24 is going to be packed. So obviously there's KubeCon, Cloud Native Con Europe in Paris. With all the co-located events, including Observability Day, since we're here in Open Observability Talks. Observability Day, a dedicated co-located event specifically for observability stack. Do check it out. Also, this is in Europe, in North America, we have Scale, the Social Linux Expo, the 21st edition. So many of the open source enthusiasts probably know this massive event. And it's actually co-located with Kubernetes Community Days LA. And the week after that, there's SRECon Americas, also in California. So, and by the way, I'll be around there. So if you are there, join my talk and let's catch up also. Anyway, lots of activities in March for the open source DevOps observability enthusiasts. So do check these out. Maybe a last note about, we talked about virtualization, going back to VMs. I talked to you about that in our chat before the live stream, but Broadcom decided to kill the free edition of ESXi, the mythological hypervisors that many of us started our journey into virtualization with that. So, and funny enough, by the way, it was announced at the I Love Free Software Day. Back in February 14th. I don't know if you know that, but it's a European thing, I think, more than North American, but there's an I Love Free Software Day. So it was very ironic to see that announcement coming exactly there. So I don't know, maybe I'm a bit nostalgic, but it felt a bit, I know that ESXi has been long not for production and just limited to one core or two cores and very dev test style, but still a moment of silence for this one. So I wanted to share with you the audience. Oh, man, anyway, David, thanks so much for joining me. That was a fascinating episode, and I can't wait to see what Preview 4 brings, and obviously to celebrate the GA, as you said, before the summer.
Before summer.
And yeah, follow David to hear more about these things. Thanks so much for joining me.
Thanks a lot.
And thank you also for all of you listeners and audience on the live stream for joining us. As always, all the episodes are available on all the favorite podcast apps, or also on YouTube on demand. And if you are listening to that or viewing that on demand, do know that we live stream the episodes on Twitch and YouTube Live, and recently started on X as well. So do follow us on Twitter at OpenObserve to get the live.
Did it crash?
I have no idea what just happened.
I was like, wait.
Yeah. Okay. Sorry about that, folks. But anyway, join us on the next month's live stream. And as always, may the open source be with you.